Alright, this is the 2013 exam, and it starts off with a ramp question. We haven't seen a ramp question in a couple of years. Alright, there's a ramp and it's angled at 10 degrees to the horizontal. There's a frictionless trolley of mass 0.5. The distance from the top to the bottom is 3.5, and the time it takes, that one's x, 2 seconds to reach the bottom. Alright, so they're giving us a lot of information. Calculate the acceleration of the trolley. At the moment it says that this is a frictionless trolley. So there's two ways that you can do this, both gets the same answer. So this is way 1 and this is way 2. Right, the first one is a formula that you might even have on your cheat sheet for a frictionless ramp. A equals G sine theta. In this case G is 10 times sine 10 degrees, and you type that in your calculator, you get 1.74 meters per second squared. Right, and then the second way is we can use this plethora of information we've got here. We've got x, we've got t, so we've got x equals 3.5, we've got t equals 2 seconds, we've got u equals 0, and we want to find a equals question mark. So we can use an equation of motion, and the one that has those four in it is x equals ut plus half at squared. Because u equals 0, 0 times t is 0, so we can just rewrite the equation x equals half at squared. And we want to find a, so we have to rearrange it, so I'm going to times both sides by 2. 2x equals at squared, and divide both sides by t squared. 2x over t squared equals a, so put the numbers in, 2 times 3.5 over 2 squared, which is 7 over 4, which equals 1.75. 1.75 here, 1.74 here, so we've got the same answer. Great. Alright, next one. This is actually one of the harder questions I felt in the exam. There's quite a bit you have to understand to really get this one. Hang on, just move this. Alright. So replace the frictionless trolley with a block of wood with the same mass. Now why would they do that? They would do that because now there's going to be a friction force when it slides down. They release the block of the wood, again 3.5 meters. When sliding down the incline there's a constant friction force, there we go, between it and the surface. I find it takes 6 seconds to reach the stopper at the bottom. Calculate the size of the magnitude of the friction force of the plane surface acting on the block. Alright, what do we know, what do we want to find out? So I'm not going to go into all the components of everything, but overall the component of gravity that acts down here is going to be mg sine theta. There's going to be some sort of frictional force acting backwards. Overall it's going to be still a force down the ramp, and that's what's caused it to accelerate and get down in 6 seconds. What I'm going to do for my working out is I'm going to think about this backwards. So the last thing I want to find out is the frictional force. To find that out I need to know the total force. To find out the total force I need to know the acceleration. So that's the way I'm going to go about it. Alright, first thing I need to find the acceleration. Right, to do that I've got the acceleration equals question mark, don't know what that is. I know x equals 3.5 again. I know t equals 6 seconds in this case, and I know u equals 0. So same formula, x equals ut plus half at squared. U equals 0, so x equals half at squared. Rearrange how I did before, a equals 2x over t squared, which now is 2 times 3.5 over 6 squared, which equals 0.0 0.19 meters per second squared. Alright, I've got the acceleration. Now I can find the total force. Total force on this block equals MA, which equals 0.5 times 0.19, the acceleration I have. 0.5 is the mass, it's the same mass as the last one, there we are. And that equals 0.0972 newtons. Alright, the next thing I was going to do is use that total force to work out the frictional force. So we've got our ramp here. Look at our frictional force. We've got, now this will be something on your cheat sheet, the force down, the component down is always mg sine theta. And those two added together give the total force of 0.0972 newtons. So those two give that. Therefore, what we've got is we've got mg sine theta minus, because this one's going down, this one's going the other way, the frictional force equals 0.0972. So what I've done is I've taken my picture here, equals the total force which I worked out, and written it as a maths equation so then I can solve it a bit easier. I know it's minus because one's going this way and one's going the other way. Put the numbers in then, so m 0.5 times 10 times sine. The angle, what was the angle? The angle is 10 degrees. 10 minus my friction force equals 0.0972. So therefore, rearrange my friction force, I add to both sides and minus that, equals 0.5 times 10 times sine 10 minus 0.0972. And I do it on my calculator, I get 0.77 newtons. Tough question, really tough question. Again, just to roll over how I did it, obviously through experience is how you get to understand these a lot better, because it's a three-part question, but I worked backwards. So I said I want the constant friction force. I could probably work it out using the total force, because I know I'll be able to work out the downwards one. And then I'll be able to work out the total force from the acceleration. The other key thing is, because I drew the forces on here, it made a lot more sense to me. This thinking came about a lot easier after I'd drawn some forces on. It got my brain working a lot easier. So don't be afraid to draw forces like that on your diagram.